Hello everyone, welcome back to our sessions on database management system. Today we are going to discuss about schema refinement. Schema refinement is a process of improving the database schema in order to ensure that they maintain the efficiency. That is, it involves restructuring of the schema to eliminate any kind of redundancy, ensure data integrity, and thus optimize the performance. So it is basically a systematic approach of decomposing the table to eliminate one redundancy. Second one is certain undesired characteristics called as anomalies. We'll see what anomalies mean. So it uses certain text. Now, what is the basic benefit of schema refinement? First and foremost, it can help you in eliminate redundancy, that is duplication, and thus saves the storage and avoids any kind of anomaly. It ensures data integrity, that is data is maintained accurately and consistency is maintained throughout the tables through well-defined relationships. It can optimize the performance by storing the data in an efficient manner and eases the database management task like updation or insertion or deletion by ensuring a clean logical structure so that there is a dependency, functional dependency is retained across the tables. What are the processes of schema refinement? First and foremost, analysis. You assess the current schema to identify what are the inefficiencies. Then apply normalizing to structure that schema in order to appropriate normal forms. Like we will learn about normalization techniques in the next slides. So we try to split the table or structure them with smaller tables. Decomposition is again helping in normalization by breaking down the larger tables into smaller to eliminate redundancy and ensure that the dependencies are preserved. Then comes the validation, where we ensure that the decompositions are lossless and they preserve the dependence. That is like you are splitting them into multiple tables, but if you join those tables, you should be able to reproduce the original structure. That is what is preservation. Then optimization is fine tuning the schema for performance by indexing, partitioning, and some other techniques. Now, first and foremost, we said there are certain anomalies which leads to schema refinement. Why we want this refinement of the schema? So anomalies are nothing but the problems occurred due to our poor planning, unnormalized. Now just look at this particular table. This table is storing all the information about the students and the courses that they take, what is the fee structure and everything. Now because of this, if you observe, every student, when he takes up or registers into multiple courses, the details of the students are repeated again and again. See, S1 student A takes up course C1 and he also takes up a course called as C2. So the details of student as well as the details of the courses are also repeated. See, C1 is taken by both S1 and S2, C2 is taken by both S1 and S3. So the course details are repeated, the student details are repeated. This is because I have put all the data into single table. The schema refinement is basically to help me to reduce this particular repetition. So the problems due to redundancies, it takes lots of space by repeatedly storing. It will have update, insertion and deletion anomalies. Now, update anomalies or these and the difference, that is inconsistent data. Now let me look into, this is called as update anomalies because each and every row I need to make this change, otherwise it is going to lead to inconsistent data. Now comes the insertion anomaly. Now assume the same table. Now we have students taking up courses. Now assume in case if I want to introduce a new course. Now in order to introduce a new course, look at this particular thing. I am just offering a course C4 which is on databases of fee structure of 12K, but there are no students. So I cannot keep it null because student ID may be, and student ID and course ID generally are the candidate keys. So primary key if I take as student ID, then that can never be null. So I have to put some dummy values, duplication. Okay. Now this is like, because I cannot insert students without having the course, either I have to wait for the students to come to introduce the new course, or otherwise I have to put dummy values which cannot, it will be forceful. So that is insertion anomalies. Coming to deletion anomalies, sometimes it will so happen that if at all I have to delete a particular row, due to which some other information may be lost, some useful information. Look at this particular case. Here, if at all, say for example, student S3 leaves the organization, he wants to take away, otherwise leave the course. Now what happens automatically is, from the database I have to remove the details of student S3. Now student S3 was the only person who had taken Java course. Now when I delete this particular row, the course Java information is totally lost. This is what is the drawback with putting all the things, or otherwise unplanned schema. So these problems can be overcome by using decomposition technique, or normalization and decomposition technique. So decomposition is nothing but is a process of breaking down into parts or elements. So it is going to be, that is a big relation is divided into smaller, smaller relations. So it will have one table into multiple tables. So care has to be taken that decomposition should be always lossless. That means it should not lose the data. The tables, when they are split into multiple tables, on completion, or otherwise when I want to join them back, I should ensure that they will be able to reconstruct the original table without any loss or damage. Now, why we want decomposition? We already said that we want to reduce redundancy and we want to maintain them as smaller tables to avoid repetition. Now there are basically two types of decomposition. One is lossless decomposition, which is the most required kind of decomposition. It ensures that the original table can be reconstructed from the decomposed tables without any loss of information. So in statement, if you have to put, the decomposition of relation R into R1 and R2 is lossless when the join of R1 and R2 will yield the same relation R. Okay, that is, the relation table is decomposed into two or more smaller tables in such a way that the designer can capture the precise content of the original table by joining the decomposed parts. In such a situation, this is called as lossless join or non-additive join decomposition. Remember, inconsistent table. Now comes the insertion anomaly. Now assume the same table. Now we have students taking up courses. Now assume in case if I want to introduce a new course. Now in order to introduce a new course, now the problems related with decomposition is that itself it may lead to lossy decomposition where data is lost. It will increase the complexity because the table is divided into multiple tables, and managing multiple tables and their relationships may become complex. Performance overhead. Now when I want certain information, in order to get that complete information, I have to make several joins. You have already learned what are joins in DBMS or databases. So I need to join multiple tables in order to get certain information. Then dependency preservation is the biggest challenge when you are dividing the tables into multiple smaller tables. Now one example I can just give here is, if you have an original table with student ID, student name, course and instructor, I can create smaller tables which are going to be self-dependent, like see, student ID and student name are interrelated, so I put them into one table. Course and course instructors are interrelated, I put them into another table. Now which student has enrolled into which course, I put that as a separate table called as enrollment. Now there is clarity, there is no anomalies of insertion and deletion. See, because course is separate. If I want to introduce a new course, I am most welcome. I need not wait for the student to be joined. If I want to have a new student, I can introduce. And when student takes up the course, the student number and course together, row goes into, one row is inserted into enrollment. So now properties of decomposition is, it should be lossless, it should be preserving the dependencies, and there should not be any redundant data, lack of redundancy. So when I say decomposition should be lossless, I should ensure that all the data should be able to, I should be able to reconstruct the original table by joining all the multiple tables that we have. Similarly, department employee ID determines the employee name and the age, city he belongs to, and salary. So all of them are in one table. So I am observing the inconsistent data. Now comes the insertion anomaly. Now assume the same table. Now we have students taking up courses. Now assume in case if I want to introduce a new course. Now in order to introduce a new course, look at this particular thing. I am just offering a course C4 which is on databases.